In the second video, I'd like to show you how to run VEAM from the command line. It's very straightforward, and I'd like to show you some files that we generate with VEAM and files that we use to run VEAM. And ultimately, I want to show you the other Python script that we've developed at the University of South Florida to change these cumulative density function model results into actual recurrence rates for our volcanic field. So here I have my directory open in the command line that has the VEAM GUI Python script and the original VEAM Python script both in this. Today I'm just going to be using the VEAM GUI Python script again, but in order to run it, all you have to do is run VEAM GUI. It's an executable, or I've made an executable here. If you don't have it as an executable, you can likely run it as python space VEAM GUI.py, but here I'm going to run it as an executable, and it loads just like it loaded from our IPython console in Spider earlier. Here we have this GUI once again, and I'm going to load a configuration file, and let me actually show you what a configuration file looks like. In this case, here's the last configuration file that we have that we loaded earlier in the previous video. It has some inputs here, and these inputs correlate, or these inputs directly relate to one of the GUI's functions in this, or one of the GUI's widgets. So you can see the maximum field age and the minimum field age are represented as two lines in this configuration file. These are the database files that we have. Right here is the ages database file that was assembled by Chris Perry and Orly Zherma at the University of South Florida. Each event here has its own line, its own age, its own uncertainty, and some other information that you can see. And then this is the stratigraphy database that was also developed, or the file was developed by Chris Perry and Orly Zherma. So here we have older events on the left and younger events on the right, separated always by a comma in this version of VEAM. And you can see that there are many stratigraphic relationships that we see at the last volcano. We're actually still going to be running the RCO volcanic field that's in our EPSL papers, so we can open up that and I'll show you that ends up looking sort of the same. We have our event ID, our age, our uncertainty in millions of years, and then some other information to the right. Let's close this out and minimize it to come back. So let's load the configuration again from the command line this time. Here, let me navigate to the database that I want. Oh, I loaded that as a configuration file, and I guess I can just do that actually instead of loading it myself. I'll use the RCA configuration file here. Open that up, and you can see again we have all of the inputs that we used from the last go around. And let's check these inputs. No errors identified, and run VEAM 100 times. We'll plot the results once more and see that these results are about the same as we saw in the previous video. We can save the figure and save the data again. Let's just go ahead and save the data in this results directory, and let's just overwrite rca.dat. Yes. So now we've saved the data, and let's close this. We've run through VEAM now on the command line, and when you're in the command line, it seems to give some warnings about parents, and I don't think that this hasn't changed anything with how VEAM runs for us, so feel free to just ignore it unless it causes it seems to cause a big problem. Then contact me. So now let's actually use this data to model the recurrence rate of the field. And to do that, we will use this file cdf2rr.python. Let's also take a look at what the data actually looks like that VEAM is exporting. So here in results we have our rca.dat file now. Here's rca.dat. You can see it puts out 7 header lines that are a brief reiteration of the configuration file. Then we have an 8th line that has the actual volcanic event names. And then each line here, there should be about 100 of them. And there are, corresponds to dates of that event. So each line is one VEAM simulation. Right now we're going to change the dates that we have here into a cumulative distribution function and a recurrence rate for this field. And we're going to plot it, and ultimately you can save that plot in this Python script with some small modifications. So cdf2rr, let's figure out where that is. So in our command line terminal, we have a directory in this VEAM directory called ratecalc. So if we ask what's in there, you can see that that's where our recurrence rate Python script is, and we have a second Python script here that actually incorporates volumes if you have volume estimates for events in your field. Today we're only going to be focused on this field that we don't have volumes for. So let's cd into the ratecalc directory, and we're there. And we can run this using in the command line. So of course this requires just a couple of modules, including matplotlib. Nothing not standard like in the GUI. It gets rid of some header lines that we just talked about, and even though VEAM ran for all dates between 0 and 1 gigaannum, 1 billion years, we're just going to look at 10 million year time steps up to 350 million years. We're just going to plot that data in that window where we think the volcanic field was most active on RCA Mons. This is on Mars. So let's run it. Again, I've made an executable. You can just type in Python space and then the name of the file if you'd like, cdf2rr.py. And then we have to include the location or the path to our results database that VEAM printed out. So that's at example results rca.dat. And we'll run it, and it will calculate the cumulative density function, the recurrence rate, and then plot 2 side-by-side plots. And here they are. You can see they're a bit cramped right now, but let's blow them up and look at what they seem to look like. Here you can see we have 100 individual simulations plotted in the background in gray, and this looks a lot like what we saw in the actual VEAM output, so nothing new here. This is the mean cumulative, the mean number of cumulative events expected through time, and this is our uncertainty envelope here in the dotted line. Here is the recurrence rate. It seems like matplotlib really doesn't care about spacing here, but here we see that after 250 million years, the event rate pops up until about 150 million years, where it's about one event per every 0.4 million years, or it takes about 2.5 million years to have one event on average. And then that drops off until perhaps around 50 million years. So let's compare that to the result that we saw in that we published, and that's figure 4 on page 5. So let's check that out, and you can see that our this instance of VEAM with a GUI and our recurrence rate follows these plots pretty closely. Now this was done with 10,000 model runs, and our example here today in this video uses 100 model runs. So it's not exactly precise, but you can see that the general shape is preserved here. And that's basically how we got our results for this paper. So feel free to use the VEAM GUI either in Windows and Spider, or in using IPython, or in Linux in IPython, Spider, or just on the command line. It should work, and if it doesn't, feel free to let me know. And I hope both of these videos have helped you understand how we model, or how we actually run this model, and good luck figuring out your own recurrence rates.